Hello, my name is Justin Hergott, and I will be talking to you about development for machine learning. To give you a little bit of a background, I had pretty much zero experience with machine learning before doing this presentation. There was a great presentation last week that explained what machine learning is, so I figured I would focus more on the development side. In this presentation, I will go over the difference of machine learning and deep learning, some definitions of terms used throughout the presentation, what language you are likely going to use for development, some popular libraries and frameworks, and some places to find more information for people who are interested. Hopefully by the end, you feel that I have given you a few good starting points that you can reference to start development with machine learning. The first thing I came across when trying to find some libraries and frameworks was that people kept making the distinction between machine learning and deep learning. Machine learning is a broad term that is used to describe the subset of artificial intelligence that uses algorithms to process some data, learn from it, and then be able to make decisions based on what it has learned. Deep learning is a subset of machine learning where artificial neural networks are used to analyze a larger amount of data and the application can learn on its own continuously with the inputs given. A good analogy for this is a program that turns on the lights when someone says dark. A machine learning program will be fed information for it to recognize the word dark and turn on the lights. A deep learning program will be fed information about the word dark and be able to turn on the lights too, but over time, as you use the application, it will start recognizing turn on the lights and I can't see as additional commands for turning on the lights. These are some additional terms that will come up during the presentation that I need to look up, so maybe they will be helpful for you too. Symbolic math. This is another name for computer algebra, which is the scientific area that refers to the study and development of algorithms and software for manipulating mathematical expressions and objects. MNIST dataset. The MNIST dataset is a database of images of handwritten digits that has 60,000 examples for training and 10,000 examples for testing machine learning programs. Neural networks. Neural networks are computing systems that are vaguely inspired by biological neural networks to create a framework for many different machine learning algorithms to work together and process complex data. Convolutional neural networks. Convolutional neural networks are a type of deep neural network that uses a variation of multilayer perceptrons to decrease preprocessing. They are most commonly used to analyze visual imagery. Recurrent neural networks. Recurrent neural networks are a class of neural networks where connections between nodes form a directed graph along a sequence and use their internal state to process sequences of input. Tensor computation. Tensor computation deals with the manipulation and calculation of tensors, which are geometric objects that map vectors, scalars, and other tensors in a multilinear manner. Eager method. The eager method is a general independent way of training machine learning systems. As opposed to lazy learning, post-training queries will have no effect on the system itself. While looking for some popular frameworks for machine learning, it became obvious pretty quickly that if you want to do anything, knowing Python would be a good skill to have, as the most common front-end components were written in it. Some of the frameworks supported Python 3.6, but most of them supported Python 2.7. If anyone was curious like me, Python is usually chosen as the primary front-end component because it is an easy, high-level language. It is popular among other professions that are interested in machine learning, such as data scientists and researchers. It also has accumulated many ready-to-use libraries that complement the use with datasets. Some examples of these include NumPy, Matplotlib, and Pandas. NumPy brands itself as the fundamental package for scientific computing that includes a powerful n-dimensional array object, tools for integrating C, C++, and Fortran, and useful linear algebra and random number capabilities. Matplotlib is a 2D plotting library, and Pandas is an open source library that provides high performance, easy to use data structures and data analysis tools. When looking for the most popular machine learning libraries, I found a few names that kept popping up. TensorFlow, Keras, Microsoft Cognitive Toolkit, and PyTorch were the most common. TensorFlow seemed to be the most popular when I started, but as the search continued, it seemed that many people are starting to move to PyTorch as they feel TensorFlow has become clunky. TensorFlow is a symbolic math library. It can be used in machine learning to create neural networks and is currently used in both research and production at Google and a wide range of other popular companies such as AMD, Nvidia, Uber, Snapchat, and Coca-Cola. It was originally a proprietary machine learning system called Disbelief, developed by Google Brain. After gaining a lot of popularity throughout many alphabet companies, Google assigned a team to refactor Disbelief into a faster, more robust application-grade library. TensorFlow was released in November of 2015 as an open source project under the Apache 2 license. TensorFlow is cross-platform. It's available on 64-bit Linux, Mac, and Windows, as well as iOS and Android. Its flexible architecture allows for use in computation across a variety of hardware, CPUs, GPUs, and TPUs, and platforms, desktops, server clusters, or mobile and edge devices. As of June 2016, Google said TensorFlow was mentioned in 1,500 GitHub repos, of which only 5 belong to Google. Since TensorFlow's release, Google has also released the TPU that I mentioned before, which is a tensor processing unit. A TPU is a hardware chip built specifically for machine learning and is tailored to TensorFlow. They also released TensorFlow Lite, which is a TensorFlow stack specifically for mobile development. TensorFlow is written with highly optimized C++ and uses CUDA, the parallel computing platform and API made by NVIDIA used to communicate with the GPU. It has a Python interface which seems to be primarily used, but is also compatible with Java, C, Go, JavaScript, and Swift. If you go to the TensorFlow website, they have an interactive tutorial to run some sample code in Colab. The code on the screen is the complete code from the tutorial that will walk you through loading and preparing the MNIST dataset, building a model, and then training and evaluating the model. As you can see, it is really not a lot of code. There is a link on screen that will take you to the Colab, which will allow you to run the code. To run the code, you need to connect to a Python runtime by selecting Connect in the top right corner. You then need to select Run All from the Runtime menu at the top. The GIF shows you how to do it. You can pause the video and go to the page now to see it in action. If you ran the code, you'll see at the bottom of the output that you just trained an image classifier with about 98% accuracy on this dataset. So that means you just trained a program to be able to identify handwritten numbers with 98% accuracy. The next framework I found was Keras. Keras is an open source neural network library written in Python that is capable of running on top of TensorFlow, Microsoft Cognitive Toolkit, or Theano. It was designed to enable fast experimentation with deep neural networks by being user-friendly, modular, and extensible. Its primary author is Francois Chollet, who is a Google engineer. It was released in March 2015 on GitHub under the MIT license. In 2017, Google decided to support Keras in the TensorFlow core library. If you look at the previous TensorFlow example, you will see it was using Keras. Keras contains many implementations of the basic building blocks for neural networks such as layers, objectives, activation functions, and optimizers. It also contains a number of tools to make working with image and text data easier. Keras can also support convolutional neural networks and recurrent neural networks. Here is the Getting Started 30 Seconds to Keras guide from their website. As you can see, it is only a few lines just like the TensorFlow example. This example walks through creating the simplest type of model, the sequential model, which is a linear stack of layers. There is a link on the screen if you want to check out the tutorial on the site. The site also has a link to the examples folder on their GitHub repo. The examples folder has some more advanced models. The Microsoft Cognitive Toolkit is an open source deep learning toolkit that describes neural networks as a series of computational steps via a directed graph. It allows users to easily realize and combine popular model types with the option of automatic differentiation and parallelization across multiple GPUs and servers. It was released on GitHub in April 2015 under the MIT license. Microsoft hopes that the community will take advantage of the Cognitive Toolkit and be able to advance ideas quicker through the sharing of working code. The toolkit is available on Windows and Linux and can be combined with the higher-level Keras API. The toolkit is available in Python, C++, BrainScript, and C#. The mainly used language seems to be Python, as there are 26 tutorials on the Microsoft website that use Python, 3 that use BrainScript, and 0 that use C++ or C#. BrainScript is a language specific to the Cognitive Toolkit that is used to describe a neural network in a code-like fashion using expressions, variables, functions, and other common coding concepts. The Cognitive Toolkit provides an example doing the same thing as the previous TensorFlow example, training an image classifier with the MNIST data. The link on the screen will direct you to the code for this example. As you will see, it's a little larger than the examples for TensorFlow and Keras. PyTorch is an open source, deep learning platform that touts its ability to provide a seamless path from research prototyping to production deployment. It provides two high level features: tensor computation with strong GPU acceleration and deep neural networks. PyTorch features a hybrid front end that can seamlessly transition between eager mode and graph mode. PyTorch is cross platform between Linux, Mac, and Windows and can be used with Python 2.7, 3.5, 3.6, 3.7, or C++. PyTorch was based on Torch, which was a package that included an open source machine learning library, a scientific computing framework, and a script language based on Lua. Torch was originally released in October 2002. PyTorch is primarily developed by Facebook's Artificial Intelligence Research Group and was released in October 2016 on GitHub with a custom license. The license allows for redistribution of the source or binaries with or without modification as long as it contains the same license and conditions. Facebook also operated a framework called Cafe2, but it was difficult to transform models between it and PyTorch. Cafe2 was merged into PyTorch at the end of March 2018. In September 2017, Facebook and Microsoft created the ONNX project, which stands for the Open Neural Network Exchange Project, for converting models between frameworks. There is a tutorial to train an image classifier with PyTorch as well. It looks to be a little more involved than the TensorFlow and Keras examples. There's a link on screen now to Deep Learning with PyTorch, a 60-minute blitz. Take a look to compare the amount of source code with the other frameworks. If you are interested in taking a course to learn more about machine learning, there are two that came up quite frequently in recommendations. There is a course offered on Coursera for machine learning. It is offered by Stanford University and says the course will take approximately 55 hours or 8 weeks at 7 hours per week to complete. It's $79 with a certificate of completion at the end, or free if you forego the certificate. The other course that comes up quite frequently was the Udacity Intro to Machine Learning course. It says the timeline is about 10 weeks and is also free. There is a related course called Artificial Intelligence for Trading, which gets you a nano degree. The nano degree consists of 2 terms and was about $1,000 a term. There is also a newer course offered on Coursera through a website called deeplearning.ai that is taught by the same instructor as the other machine learning course. This one looks to be a little longer at 3 months to complete. This course is split up into 5 smaller courses by category: Neural Networks and Deep Learning, Improving Deep Neural Networks, Structuring Machine Learning Projects, Convolutional Neural Networks, and Sequence Models. The only information I could find for pricing was that there is no free option for this course and will cost about $49 a month, $150 for the estimated 3 months it will take. The deeplearning.ai site is advertising another course called AI for Everyone, coming early 2019. Here are some activities for you to see machine learning in action. The first one is the emoji scavenger hunt with Google's TensorFlow.js library. You can follow the link on your phone to play the game. It will show you an emoji and you have to point the camera at that thing in the real world. For example, if it shows you the TV emoji, point it at your TV. It should work on Chrome if you have an Android and Safari for iOS. It didn't work on my older Nexus 5, but did work on a P20 Pro. Another site I found was the Imager demo. You can either upload a photo or select one of their sample photos and it will generate some tags for it automatically. That's all I have for my presentation on machine learning. Hopefully you found this helpful and now know some places to start if you want to learn more or start developing with it. I will put all the links for the activities and references in the description below.